Good morning, friends. Today I'm going to discuss the third part of unit number 6, that is two-port network. To explain this part, I am referring a book, reference book, Cobra Gade and Nike. A very nice book which have given the complete details about this two-port network. In the syllabus of third sem electrical network analysis, there are three parameters to understand under two-port network. First is impedance parameter, second admittance parameter, and third is ABCD parameters. So let us start with the introduction to this two-port network. All the networks are basically a two-port network. The definition of two-port network, where we have two terminals given, one as input terminal. You can see in the diagram, which is represented as 1 dash with the input voltage V1 and current I1 connected to a two-port network, and the output terminal is V2 connected between 2 and 2 dash. So output voltage is V2 and corresponding current is I2. Now, these two-port networks basically having represented in three parameters, in three forms of parameters. One, as I said, impedance, admittance, and third is ABCD. So we are starting with first open circuit parameters. Open circuit parameters, let us say I1 and I2 be the independent variables and V1, V2 be the dependent variables. The network equation can be written as V1 is equal to Z11 I1 plus Z12 I2, that is input voltage, and V2 is equal to Z21 I1 plus Z22 I2. These Z11, Z12, Z21 and Z22 can also be written in the matrix form. Okay. So therefore, we have the modified circuit where the impedance parameters are replaced to two-port network. Now, we are forming the equations for the respective impedance parameters. So let I2 is equal to 0. That means you have to open circuit the output port. As soon as you open circuit the output port, I2 makes it 0. It makes it I2 equal to 0. So when this I2 equal to 0, what we can write is Z11 is equal to V1 upon I1 and Z21 is equal to V2 upon I1. Now, in second case, make I1 equal to 0. It means make input port open. As soon as you make it, what you get is Z12 equal to V1 upon I2 and Z22 is equal to V2 upon I1. What are those four parameters? Z11 is driving point impedance at input port. Z22 is driving point impedance at output port. And Z12 is reverse transfer impedance. Z21 is forward transfer impedance. Those equivalent equations can be represented in this particular circuit. As we already said, I1 and I2 be the independent currents and V1, V2 be the dependent voltages. Okay. Now, V1 is equal to Z11 I1, right, plus Z12 I2. So this particular symbol is representing the dependent voltage source. This dependent voltage source is having a value of Z12 I2. Similarly, on this side, Z21 I1 is dependent voltage source of the secondary side, which is as Z21 I1. And Z11, Z22 be the driving point impedance of input and output port. Okay. So this is simple introduction to the equation formations, and when the input and output ports are open circuited, which makes I1 and I2 0 respectively. Now, let us derive the condition of reciprocity. This is generally asked in the examination if the derivation is asked. So condition of reciprocity can be derived by short circuiting the output port and connecting source voltage on the input port. So if the source voltage is connected in input port, we can say Vs is equal to V1, and due to short circuit, that V2 is equal to 0. Now, as we know, whenever we have a output voltage V2 present, I2, the direction is anti-clockwise. But due to this short circuit, the direction of that I2 is changing, which is represented as I2 dash. So it is opposite, and therefore I2 is equal to minus I2 dash. Now we are stating these three conditions: Vs is equal to V1 or V1 equal to Vs, V2 equal to 0, and I2 equal to minus I2 dash. Put these three conditions in the equations. Equation V1 equal to Z11 I1 plus Z12 I2. That makes it this equation, and V2 equal to Z21 I1 plus Z22 I2. So that gives you this 8.4. Further, 8.4 can be solved to get the value of I1. Now put this I1 in 8.3. You get Vs is equal to this, and by taking I2 dash common, what we are getting is Vs upon I2 dash. It means it relates what? The input source voltage with the short circuited current on the secondary port, that is secondary side. So Vs upon I2 dash is equal to this. This is Vs upon I2 dash. Similar way, in second step, now short circuit the input port and give source voltage input energy on the second port. What do you get? V2 is equal to Vs, V1 equal to 0, and I1 equal to minus I1. It is similar to the first case. Again, by putting these three conditions in the previous equations, what you get is this, and therefore you are forming the equation for I2, that is 8.7. Put it in the second equation, what you get is 8.8. Now put 8.7 in 8.8, you get the value Vs upon I1 dash. Vs is input voltage, and I1 dash is again the short circuited output current. So this is 8.9. Now let us write the first equation 8.6, right? Which is again input voltage upon output current. So you just check this Z12 and Z21 is only the different. Otherwise, the rest of the equation is same. So for the network is to be reciprocal, means similar, reciprocal. Z12 must be replaced by Z21. So this is the condition called as reciprocity condition, reciprocal condition. So thus for a network to be reciprocal, its reverse transfer function should be equal to its forward transfer function. Okay. Now, another is condition for symmetry. Apply voltage Vs at 1 dash. Okay, and second port must be open circuited. So what do we get? V1 is equal to Vs. Second port is open, means I2 equal to 0, and therefore Z1 is equal to Vs upon I1. Similar way, in second step, apply Vs on second port and make 1 dash open. That makes it I1 equal to 0. When it makes I1 equal to 0, put it in the second equation, you get the equation for Z22. So by putting I2 equal to 0 in equation 8.1 and I1 equal to 0 in equation 8.2, you are getting Z11 and Z22. So Vs upon I1 equal to Vs upon I2. That means Z11 equal to Z22 is the condition for symmetry. Thus, a two-port network is said to be asymmetric if the ports can be interchanged without changing the voltages and currents. Okay, so that's all with this particular introduction to two-port network, impedance or open circuit parameters.